All right, so we're going to get started on the last chapter of the school year, which is chapter number 9. Okay, so today we're going to start talking about right triangle trigonometry, and our goal is to talk about the 6 trigonomic functions and special right triangles. So I have a bunch of information to start us off with. And the beginning is actually a review from geometry. Okay, so if you remember in geometry, you learned SOHCAHTOA. That's the mnemonic device that we use to help us remember how to set up the trig ratios for sine, cosine, and tangent. The sine of the angle, and in Algebra 2, we're going to use this Greek symbol to represent the acute angle. The Greek symbol, it's a Greek letter known as theta. So we say sine of theta, sine of the acute angle, is equal to the opposite over the hypotenuse. Cosine of theta is equal to the adjacent side over the hypotenuse, and tan of theta is equal to opposite over adjacent. All right, and this is only true in right triangles with theta being an acute angle. So that goes along with the diagram I drew up here. All right, this is a right triangle. So one of these two angles would be theta. It doesn't really matter which one, depending on the problem. This one might be marked as your unknown theta. That one could be as well. All right, and then based on where theta is, you label the sides of the triangle. The side across from theta, that's your opposite. Here's your adjacent. And your hypotenuse is always across from the right angle. If this one was theta, then that would change. My opposite side would be this side, my adjacent side would be that side, and the hypotenuse never changes. Okay. Now there are additional ratios which you probably did not learn in geometry. The additional ratios include their reciprocals. So 3 new ratios that we're going to talk about today are cosecant, secant, and cotangent. All right. Secant is the reciprocal of sine. If you look at sine opposite over hypotenuse, if you take the reciprocal, flip it, hypotenuse over opposite. So cosecant is the reciprocal of sine. And then secant is the reciprocal of cosine. Cosine is adjacent over hypotenuse, flip it, and it's hypotenuse over adjacent. And then cotangent is the reciprocal of tan. So you flip this ratio to get adjacent over opposite. Okay, so I wrote it out 2 different ways. You could also write the cosecant function as 1 over sine, because the reciprocal of sine is 1 over sine. The reciprocal of cosine is 1 over cosine, and the reciprocal of tan is 1 over tan. All right. Now, you will want to remember which ones are reciprocals of each other. So this is just kind of one way, one little trick. Move this down. One little way, one little trick of remembering sine and cosecant, S and C. All right. And then over here, C and S. So they're kind of paired with the opposite letter. Right? Sine and cosecant, cosine and secant. So C is paired with an S. And then tan and tangent. I think it's pretty easy to remember that they're paired together because they both have tangent in their name. Okay, so that is the bulk of the information that we're going to be using for the problems that I'm going to set up next. So let me just erase the board and I'll get our problem started. All right. Okay, so to get us started, we're going to evaluate the 6 trig functions of the angle theta. So I'll write those directions down. We're going to evaluate evaluate the 6 trig functions of theta, the angle. Okay, so the diagram that's given for this problem, we have this right triangle. Theta is here, and then 2 of the sides are 7 and 24. So if I ask you to evaluate the 6 trig functions, I'm asking you to evaluate setup, sine, cosine, tangent, cosecant, secant, and cotangent. Okay, so we'll just write them out first. Sine of the angle. So if you want, you can always write SOHCAHTOA right on the top of your page somewhere to help you remember how to set up the trig ratios. So sine is opposite over hypotenuse. Then we're going to go to cosine of the angle, cosine of theta. Cosine is adjacent over hypotenuse. And then tan of the angle. Tan is opposite over adjacent. All right, that's 3 of the 6. Now the other 3 are the reciprocal functions that I introduced you to today. All right, so you have to, again, remember which one is the reciprocal of sine. Remember the trick I said, C and S go together. So sine is paired with cosecant. Cosecant is its reciprocal angle. So cosecant of theta is just going to be the reciprocal. So that's going to be hypotenuse over opposite. And then cosine pairs with, remember C and S pair together, so cosine is paired with secant. So secant of theta is the reciprocal, so it's going to be hypotenuse over adjacent. And then the reciprocal of tan is cotangent, so cotangent of theta, the reciprocal, adjacent over opposite. Adjacent over opposite. All right, so what you need to do now is label the triangle opposite adjacent hypotenuse. So here is theta, so the side across from theta is always going to be your opposite side. The one across from the 90-degree angle is always going to be your hypotenuse side. And then the one next to theta, but not the hypotenuse side, is your adjacent side. All right? In order to set up all the trig ratios, I need to know the 3 sides of the triangle. And I only know 2. So what is a method that we can use to solve for the missing side? Pythagorean theorem. All right, a squared plus b squared equals c squared. So that's what I'll do here. A squared plus b squared equals c squared. A and b are 7 and 24. So 7 squared plus 24 squared equals c squared, or hypotenuse squared. All right, so I'm going to have 49 plus 576 plus 576 equals c squared. All right, you're going to add together and then take the square root. So that's 625 equals c squared. Take the square root, so c equals 25. All right, so you do need to do that. Excuse me a second. All right. I have a little puppy in the house. Here, take her and go in the other room. Okay. But then we shall her. Sorry about that. All right, so you do have to solve for the hypotenuse before you can set up the trig ratios. All right, then from there, it's just really pulling the numbers, simplifying when necessary. All right, so sine of the angle, again, is opposite over hypotenuse. So that's going to be 24 over 25. Then it's going to be adjacent over hypotenuse, 7 over 25. And then you're going to have opposite over adjacent, 24 over 7. All right? And then the reciprocals are fast. You just flip all those fractions. You don't even really have to look at the triangle. You can just look at the fractions next door. So 25 over 24, 25 over 7, and 7 over 24. Now, if any of those could be simplified, you would definitely need to simplify the fractions. All right, but you do want to leave them in fraction form. All right? Okay, so I think that is all we had to do for that problem. Yes, that is it. All right, so let me erase that and get the next problem started. Okay. So the next problem says, in a right triangle, theta is an acute angle and sine of theta is 5 over 6. Evaluate the other 5 trig functions of theta. So let me write that in. So in a right triangle, theta is an acute angle and sine of theta is equal to 5 over 6. Evaluate the 5 other trig functions of theta. Okay, so the first thing I would suggest doing is draw a right triangle, right? At least we have some kind of visual to go with. And then put theta in one of the spots. It doesn't matter which. I'll put it up here just because it matches my notes. Okay. And then, just like we did for the last problem, I'm going to set up the 6 trig ratios. I probably should have left them all up to save time. Sine, cosine, tangent. All right, sine is opposite over hypotenuse. So Katoa will help you if you forget these. Adjacent over hypotenuse. Opposite over adjacent. And then they're matching reciprocals. So sine matches with cosecant. Cosine matches with secant. And tan matches with cotangent. Okay. And they're the reciprocals. So I can write that up again as well. Hypotenuse over opposite. Hypotenuse over adjacent. And adjacent over opposite. Okay. Now, one really important piece of information that was given in the word problem was that sine of theta is 5 over 6. Okay, so I can write 5 over 6. And that right there tells me my opposite side and my hypotenuse side have lengths of 5 and 6. So let's actually go through across from theta. This is going to be your opposite side. Across from the 90, that's your hypotenuse side. And then next to theta, this is your adjacent side. All right, so you're given the opposite side is 5 and the hypotenuse side is 6. So 5 and 6 can go in there. To find my adjacent side, I'm going to again use Pythagorean theorem. A squared plus B squared equals C squared. So A squared plus 5 squared equals 6 squared. So I have A squared plus 25 equals 36. You're going to subtract 25 from both sides to get 11. So A squared equals 11. A equals the square root of 11. By the way, it's not plus minus. Typically, if this was just an algebra problem not related to right triangles, we'd have A is equal to plus minus root 11. But you can't have a side of the triangle that's negative, so we ignore the negative and just take the positive. Okay. So now I have all my different lengths. I can go in and fill in all the ratios. All right, so cosine is adjacent over hypotenuse, so root 11 over 6. Tan is opposite over adjacent, so 5 over root 11. And then the reciprocal, so I just flip each of those fractions. 6 over 5, 6 over root 11, and root 11 over 5. Now, are there any issues with any of these fractions? So first look through, do any of them need to be simplified? Do any of them need to be rationalized? You do have to rationalize this one here, tan, and I'm noticing I forgot all my theta symbols, by the way. Tan and secant. You can't leave root 11 on the bottom of the fraction. So I'm going to rationalize by multiplying top and bottom by root 11. So when I multiply top and bottom by root 11, I have 5 root 11 over 11. And over here, multiply top and bottom by root 11, you're going to have 6 root 11 over 11. Okay? So those would be the answers. These would be your final answers here. All right, and what I said was I forgot to put all my theta symbols in. It should be secant, cosecant, tan, theta. I was rushing, I guess, and forgot those theta symbols. Don't forget yours, please. Okay. All right, so that is how you go about doing that. All right. And then let me just put up a few little reminders. like 4 little reminder problems, just some stuff from geometry that'll be helpful to remember for this chapter. All right, so in geometry, you also learned about special right triangles. Special right triangles. There was 2. You had a 30, 60, 90 right triangle, where you'd have your 30-degree angle across from your smaller side, your 60-degree angle across from your longer side, and then your right angle. All right, and the 2 relationships here are that your hypotenuse is always equal to 2 times your shorter leg, and your long leg is equal to root 3 times your shorter leg. So you would label the short leg x, the long leg x root 3, and your hypotenuse 2x. Hopefully you're remembering this from geometry. The other special right triangle you have is a 45, 45, 90. A 45, 45, 90 is a right triangle that also is an isosceles triangle. Because if both of these angles are 45, then that means the legs are congruent to each other. All right? In this triangle, there's just one relationship you need to know. Your hypotenuse is equal to root 2 times your leg. So your legs would both be labeled x, and your hypotenuse is x root 2. Okay? So, for example, I'll put 2 problems up real fast after you guys take a look at that. Actually, maybe I can... No, I won't do them on the side. I'll erase and do them on the board. Okay. So 2 quick examples of 30, 60, 90. So the reason we have special right triangle information is because if you're only given one side of the triangle and you can't use Pythagorean theorem, if it happens to be a 30, 60, 90 right triangle, you can solve for the other 2 sides. Okay, so for instance, what I'm saying is if, I'm trying to remember what information I gave. I'll do this one. If I give you just the hypotenuse is 12, right? Well, based on that information, I can't use Pythagorean theorem to solve for the missing 2 sides, but the relationships I just explained to you was that the hypotenuse is 2 times as long as the short side. The short side is the one across from the 30. So if the hypotenuse is 12, that means that this leg is 6, because it's half of it. And the long leg, the one across from the 60, is root 3 times the short leg. So if the short leg is 6, the long leg is 6 root 3. Okay. Or if it is a 45, 45, 90 right triangle, isosceles right triangle, again, if you just know one piece, you can figure out the other 2. So for this one, if I give you that this leg is 3, well, automatically this one has to be 3 as well because it's isosceles. And now your hypotenuse is root 2 times the leg. So the hypotenuse is 3 root 2. Okay, so hopefully you guys remember that from geometry. That's just a quick review of special right triangles. All right, that's it for day 1 of lesson 9.1. So jump on over to the online textbook and get that homework done, and I'll see you back here for day 2.